Bonjour, bonjour. On y a cru, on y a cru. Vous inquiétez pas, c'est pas pris en vidéo, donc de toute manière, je peux faire ce que je veux. So now I switch in English because our next speaker will talk in English. We will talk about carbon and how to reduce the impact. But first, I would like to introduce him. He's from Clisson. So I think in Nantes, everybody knows Clisson because of the Hellfest, yeah. I'm from Montpellier, and it's my fourth time this year that I will be in Hellfest, so vive Clisson. So now I think it's time to welcome Olivier and give it up for Olivier.
Hello, everybody. Hello, Hellfest, DevFest. So today I'm going to talk about the carbon emissions of the cloud and how to reduce it. Yes, it's there. Okay, so I'm Olivier. I'm usually working for Elastic as software engineer in the releasing team, but I am taking a break to found a new project named Carbonifer. And in Carbonifer, it's basically going to be a platform where you're going to be able to measure and reduce the carbon emissions of your cloud. So here is a sentence I hear quite often. I have all my infra in the cloud, so I do not emit CO2. Yeah, cloud is magic. Everything you put in the cloud disappears. Still there, but it disappears. No, it's still relying on servers, infrastructure, network, and all of that is using electricity. But electricity is clean, right? So we consider that globally, if you take the all electricity used by ICT, which is internet technology, data centers are using 20 to 25% of it, and it's already old data. We consider that it's responsible for 1% of the worldwide electricity demand, and by 2030, the projections are showing that ICT is going to be demanding 20% of the worldwide electricity. And among that, data center are going to be responsible for maybe a third of that. If we talk about the greenhouse gas emissions of those data centers, we consider that digital technologies are responsible for 4% of greenhouse gas emissions globally. And the cloud only is emitting more than 300 megatons of CO2, which is roughly the same global emissions of countries like UK or France. And congratulations. We just overthrown civil aviation. So the cloud is emitting now more than civil aviation. So the cloud is emitting more than taking flights now. And we're focusing on flights, and we should also focus on data centers, obviously. And some projections are showing that it's going to basically double by 2030. So that's pretty concerning as human being, but as company, what is the problem? So there is a lot of regulations and compliance that are coming. And obviously, as a company, you want to attract funds. And there is a lot of ESG funds. They're going to put money in companies that they're going to show some sustainability or greenness somehow. It's also a good tool for recruiting, staff retention. You're more keen to join a company if the company is a little bit more ethical or green. It's good for customer retention, of course. And if you're using less resource, of course, it's going to reduce your costs. But what are we talking about? What is your responsibility? There is some studies, for example, for Mozilla, they showed that 98% of their emission is coming from users of Firefox. So where do we stop? Some others are considering that if you are using Spotify for focusing for work, you should account the carbon emissions of your use of Spotify to the carbon emission of your company you're working for. So where should we stop? It's crazy. So the GHG protocol came up with 3 scopes. The first scope is direct emission. So it's obviously when you are burning fuel, if you have a diesel generator. Scope 2 is your emission related to purchase of energy, your electricity bill, basically. Scope 3 is everything else, value chain emissions, also called. So it's basically your business travel, raw material purchase, and maybe your Spotify use. So if you're using a private cloud, it's scope 2 and 3, and if you're using a public cloud, it's only scope 3. Couple of regulations, will not talk a lot about those, but the one which is a little bit concerning for us European is CSRD, stands for Corporate Sustainability Reporting Directive. So it's going to be enforced pretty soon for a large company, and in 2 years for smaller companies, for scope 1, 2, and even 3. Quick tip, you need to set the perimeter of your scope 3, obviously. And some other directives are coming pretty soon. You also hear often about CO2 offsetting. What is CO2 offsetting is when you are compensating or removing CO2 from the atmosphere. So basically, it's planting tree. So you think what you want about that, but I would prefer eliminating the source of CO2, which is the other thing, which is elimination. So some companies are going to want to claim to be soon carbon neutral, net zero, or 100% renewable. What are those? Carbon neutral is basically you are not changing your emissions, you are just compensating it, planting trees again. For net zero, you're focusing on elimination and you are offsetting the rest because obviously there is some emissions you cannot reduce. And for 100% renewable, you need to be careful if it's powered by or matched by. Powered by means that you are sure that an electron coming in your data center is coming from a renewable source. So you have your own windmill and you rely only on your own windmill. Matched by is like, imagine you have solar panel on the roof and it's providing more electricity than you need for the day of your data center. But obviously, if it's solar panel during the night, you need to buy electricity on the market. So in that case, it's a little bit biased. So you think what you want about that, but matched by doesn't really mean all electricity coming from renewable sources. So now, how to measure your cloud infrastructure? So in the room, please raise your hand if you are working in a company which is operating a cloud service or cloud infrastructure. Yeah, pretty much everyone. Keep your hand up if you know the carbon footprint of this cloud infrastructure. There is one. 2, so you can come to talk with me after, because it's pretty hard to measure. So how it's working? There is a couple of ways to produce electricity. Some are clean, some are not clean. By the way, nuclear energy in this topic is considered as clean energy in the term that is not emitting CO2. And obviously coal and gas are emitting CO2, and all those electricity are mixed in what we call the energy mix in the grid of electricity, providing electricity in your data center. A little bit of this electricity is used for cooling, the building, administrative buildings, cooling, air conditioning, I said already, and but large majority of the electricities are going to power your servers and your infrastructure. So if you have a cloud infrastructure, that means that you're going to occupy a little bit of those places in this data center. So there is some ways to calculate what is the energy you are using. So the Green Software Foundation came up with this formula. It's called SCI formula, software carbon intensity. So basically it's pretty simple. The E is the energy consumed by your software. So there is some ways to calculate that. You multiply it by the carbon emitted by the energy, so basically the carbon intensity of your grid, and you add what we call the embodied emission. So I'm going to start with the last one. Yes, quick side note. We are talking in unit of gram of CO2 equivalent, because not only CO2 is emitted when electricity is produced. It can be some methane, for example, and methane is 84 times more potent than CO2. So in order to be easily understandable, we are talking in gram of CO2 equivalent. So what are embodied emissions? So basically, it's the carbon emitted during the manufacture and the disposal of your device, of your hardware. So imagine that you are buying a server, for example, which is manufactured in China, and it had emitted 4 tons of CO2 for this manufacture, which that means that every year it's going to virtually emit 1 ton of CO2. So you can do the ratio and calculation per year, per month, per hour, per minute, per second, whatever you want. So in this example, if you are using an AWS M4X large instance, which is a part of a 2 Xenon machines on AWS, you can make some calculation and consider that it's emitting a bit more than 1 gram of CO2 per hour. So the use emission is the E and the I in this formula. So it's the energy of your software. It's pretty hard to calculate it, but imagine you have it. I'm gonna, there is some tools that can help you doing that, but basically you know what is the power used by your CPU, your RAM, and you have a process using 50% of those, and you make this calculation. You multiply it by the power usage effectiveness. So the power usage effectiveness is basically how many kilowatt hour you need to inject in your data center to eventually have 1 kilowatt hour. So for AWS, for example, you need 1.2 kilowatt hour to at the end have only 1 kilowatt hour, because remember, they use electricity for cooling and air conditioning and a lot of stuff like that. And you multiply that by the carbon intensity of the grid. So I have 2 examples. In Dublin, in Ireland, it's on average during a year, it's emitting 300 grams of CO2 per kilowatt hour. For the same kilowatt hour, if your data center is based in Paris, is 52 grams. So it's really significant, the region you are choosing to put your instances. And if you do the calculation, it's pretty obvious that Paris is winning in that case. So those data are pretty much easily available. There is a very interesting project named appelectricitymaps.com. In this one, you have a beautiful map where you can see what is the carbon intensity of your local grid in live. So in this example, it was in March 22, and it's showing that in France, it's emitting a bit more than 150 grams of CO2 per kilowatt hour, and in US, it was emitting, in US, it's a big mess, but in this region, it was emitting 250 grams. Some data are less available, like the energy consumed by the type of your CPU, the type of the RAM, your model, your manufacturer, your make. Those data are pretty hard to find, but there is some data sets, and most of the time working with estimation and coefficient is way enough. The embodied emission of the hardware, again, you need to know what is the hardware you're running your software. And if you're on the cloud, if you're on AWS, GCP, or Azure, that data is pretty hard to find. But again, there is some data sets you can find. And obviously, energy mix is linked to the weather and the prediction of the weather. If it's more than a couple of days from now, it's pretty hard to guess. So how to measure it concretely? Obviously, we have some tools gonna help you. A cloud provider came up with various tools, which is pretty handy for having the global number, but it's pretty hard to use those tools to have a very fine number. You cannot deep dive. This data is pretty old, but still, you have a number. If you want to go a little bit further, you can use Cloud Carbon Footprint. It's an open source tool, and it basically reads the bill of your AWS and GCP platform, which means in the bill you have the number of instances you spin up, for how long, the number of Lambda function, et cetera, so they are making the calculation for you. Scaffolder, on the other hand, is focused on monitoring the CPU power. So it can calculate for you what is the power used by a piece of software or process, depending of what the percentage of this CPU it's using. So it's not directly CO2, but it's already the most complicated part to guess. Boa Vista is a great API, and basically you enter what is the specification of your hardware, what is the instance you're using on the public cloud, and it's giving you per hour what is the emission. And my little project and my first brick of this project is a tool for estimating the carbon emission of a Terraform project. So basically, in Terraform, you can describe what's going to be the infrastructure you want to deploy, and it's going to make some calculation and try to estimate what's going to be it. And you have a beautiful list. It's called Awesome List on Green Software Foundation website, where you have a lot of tools like that. So how to reduce it? So we're going to focus, obviously, on the usage, not the embodied emission, because the embodied emission is a little bit done already. So a good thing is use green coding, eco-design. The better your code is, the more efficient it is, the less it's going to emit at the end. The choice of the instance type, obviously, if you're working with some very new CPUs, like ARM on Gravitron, for example, on AWS, it's the best thing to do because it's going to emit way less than older CPU. A good thing to do is to move to hyperscalers, because on public clouds you can just use only the machines you're going to need, and you're not overcommitting that you could do in your own data center in your basement. Good thing to do as well is to keep it to the minimum, for example, using auto-scaling groups. Auto-scaling groups is groups of instances that's going to reduce, shrink, or grow depending on your traffic on your load. So in that case, you are using only the minimum. Serverless, same thing. Serverless doesn't mean it doesn't have server. That means it's not going to deploy anything on servers if it's not used. And as I mentioned already, change region, change zones, change country to go to a country where electricity is a little bit greener. And if you want to be a little bit fancier, you can go carbon awareness. So what is carbon awareness is, imagine you have a cloud platform which is aware of its own emission and is able to autopilot based on its own emission by resizing, moving, or scheduling. So there is a couple of examples. One is called temporal shifting. So the idea is to schedule a task not when you want, for example, at midnight during the night, but when the electricity is going to emit less CO2. So good examples are AI training, machine learning, video processing. And they're already doing that at Google for their internal use. There are scheduling tasks when automatically when it's going to get that the electricity is a bit greener than usual. So in that case, it's going to trigger more tasks. Demand shaping is for a synchronous process. For example, you are reducing the quality of the video when the electricity is emitting a lot of CO2. And it could be interesting for CI servers if you have a Jenkins, for example, which is building PRs for your developers. You can imagine that you can have less workers when the electricity is emitting a lot of CO2, which means that the developer is going to wait a little bit for having his PR built. But again, there's much of choice. And the last thing is spatial shifting. So basically, the idea is to move a part of your infrastructure to the region which is emitting the less in the area. For example, if you are targeting customers in UK, France, basically Western Europe, you can have your part of your infrastructure can move depending of where electricity is emitting the less. There is a good example, a good paper has been published in Hot Carbon 23 conference. So basically, they deployed the same infrastructure in two different regions, and they have a load balancer, which is redirecting the call from the user to one of those two data centers. And they usually take the distance, the closest, for minimizing the latency. And they change it to use some carbon awareness. So basically, it's not going to redirect to the closest data center, but to the data center is going to emit the less. And doing so, they managed to have 21% of reduction without any loss of latency. If they want to have a little bit of acceptable latency, it's going to be cut by half. So that's quite significant. But in that case, they keep two data centers up. So that's pretty much all. So in conclusion, what are the takeaways? The first thing you need to do is to collect your metrics of use of CPU, RAM, data, storage, etc., etc. And then you have some methodologies and tools for estimating the power used by your software or your piece of infrastructure. Then you have some ways to calculate your carbon emissions based on that in live. And then you put that in some Prometheus with Grafana or on Elasticsearch or whatever you want. And you can make some calculation, analyze, you correlate, and you come up with actions. Manual actions like reduction, changing the region or stuff like that. Or you can even go carbon awareness where everything is going to be done automatically. And thank you very much. I have 1 minute left for questions.